Welcome to the next chapter of our Raspberry Pi Pico load cell tutorial using Hopper. Now we're going to add a display. So this is a fairly generic display that you can find on AliExpress. So let's have a look at it. So there's a lot of budget displays you can buy, like this one, but the problem with these often is that the instructions aren't that great. So, for example, in the description it says this is an SPI interface, and then if you look at the pinouts, it's got SDA and SCL, and those are what you name the data and clock pins for an I2C interface. So, which is it, right? But it does have a chip select, which I2C does not. So with some experimentation, I discovered that this is actually an SPI display and that they just named these two pins wrong. So this pin is the SPI clock pin, and this pin here, it's the one for passing data from the microcontroller to the device. So that would be the MOSI pin, microcontroller out, right? And child in. And then it's got these two other pins, which with TFT displays, there's the obvious chip select, which is part of the SPI interface. But the TFT drivers have a DC pin, which is used to tell the device that you're sending data or a command, hence D or C. And what we can also tell from here is that our driver is based on the ST7735 chip. I don't know why it mentions replacing an OLED as well. It's just confusing. Also, we can see that it's 128 pixels by 160 pixels, and depending on whether you make it landscape or portrait, you're going to get 160 by 128 or the other way around. Okay, so let's see how that affects us. So if I just go to the console here by Alt F4 and I do a dir of source library and displays, these are the display drivers, and one of them is a TFT driver that's generic. So that's our generic TFT driver. And then what we do is we use display drivers to build devices. So if we now look at, actually, let's just go up like that, and we look at devices. So the reason for this is that sometimes a device includes more than a display, like this one includes some buttons there as well, right? In our case, our device and our display are essentially the same thing, but there are many displays which use that TFT driver and they use different chips. So if we go down in the list here on the screen, we can see that there's a 160 by 128 generic TFT driver that uses the ST7735 chip, which is what we saw on the AliExpress page. So this is most likely our driver. So to use that driver, it's in our hardware configuration because our Challenger hardware configuration might use a different driver. So in here, after we include the Pico, we're going to go users and source and library and devices, and that generic, which I don't want to type wrong, so I'm going to cut and paste it from somewhere else. So the generic 160 by 128 ST, there we go. Now, another thing that you're going to want to use is if we want to use text, we can use a device driver without drawing text, so we can just draw graphics on it if we wanted to. But if we want to draw text, we're going to need to include a font as well, right? And there's a folder full of fonts, and they're naming, and this font's going to be the same no matter which hardware we use. So we're not going to put it in the hardware thing. We're going to just put it directly in the main program. So also in source libraries, there's a subfolder called fonts, And if you look in the subs folder, you'll see lots of different names. The one I'm going to choose is Verdana, 5x8. And the 5x8 means that the character cells are 5 pixels across by 8 pixels high. So when we're trying to scale our graphics eventually, that'll come back to us. Now, if we go back there, we look inside here, every device driver will have pin configuration, and it'll have a begin method to initialize it. This one's pretty simple. So we're just going to call the begin. And all device drivers, so if we're using a different device driver, it's going to have the same unit name, so that, again, for abstraction, we don't really have that problem right now because we're going to be calling it over here. But here we can go, if not device driver begin, that means it failed, right? And then we can go io.write lin failed to initialize display and return a false, right? So we don't have a display hooked up yet, so if we compile this, users didn't find my font. Usually because I've made a typo. Let's see what I've done there. Source, libraries, fonts. Oh, library. There's no, it's too many plural and singular. There we go. Let's build that. And because we haven't hooked up our display, we expect it to fail. So if we run it now, we should get that fail message. If it works at all. Let's see what happens. So let's F5 that into the debugger. And I can show you how the debugger works again as well. So we can actually put a breakpoint on there. So F9 on there. So I pressed F9 to put a breakpoint on that line. You can find them on the menu here. They're all the shortcuts, right? And now F5 to run to the breakpoint. Now it's gray. It's stuck on the breakpoint. It's about to call initialize of the device driver. Now F10, it actually it thinks it did succeed in initializing it. That's funny. Even though so yeah, it probably doesn't do anything other than configure pins and things. It's probably the first time I try and use it, it'll probably fail. Anyway, so much for that. Now, to configure our device, let's see what we need to do. Let's first wire up the hardware, right? So we've got, let's look at those pins. So we've got ground and VDD on the left, the 2 power pins. We've got the SDA and SCL, which is the clock and data, and we've got the DC and CS. So we've got to wire up 4 pins plus the power. We're not going to wire up the reset pin because on the TFT displays, you can do software reset with instructions. So if you don't wire up that reset pin, never call it. You can just use a software reset. So no need to wire up the reset. So I'm going to quickly wire that up. And I'm going to do it off camera because then I can get my microphone out the way. Okay, let's take a look at my work in progress. I've got my power leads hooked up, and then I put a pin in each of those. And I've used the same colors for clock and data. I use yellow for clock always, and I've got blue here for data. So same colors as I used for the load cell amp for clock and data. And now we need to plug those into the board. But before we do that, let's just power up and see what happens. So that shows that power is correctly going to our LCD, but nothing else is happening. Okay. Now let's go and see how we wire up those pins. So if we go and look at the generic display, we can see that a lot of those pins have already got some defaults here. So there's a chip select pin. Let's see where that goes. If we right click on it, we'll go to its definition. So it's using, so the Pico W has 2 SPI controllers in it, and it's defaulting to using controller 0. So SS is the select pin, and that's going to 17. The clock's going to 18, and the transmit is the one we want to go to 19. So that's the device, the microcontroller transmitting data, right? So that's going to be the data pin, that's going to be the clock pin, and 17 is going to be the chip select pin. So let's go see where those pins are on the board. So 17, what did we say that one was going to be? The chip select pin. So that's the second pin from the bottom on the right. So our chip select pin is the white pin. So that's going to go into the second pin from the bottom. There we go. Just put it in there. Okay. And then we've got a ground pin to skip. And then the next one is going to be, so these pins here, the yellow ones, this is the default pins for MOSI 1. I mean for SPI 0, the 0 is there. So the next pin's the clock pin, which I know is my yellow because clock's always my yellow. And then the next pin's the data pin, right? And then we've got one pin left, which is this DC pin, which is specific to TFT. And I'm going to just put that in there. And that pin there is GP12. So it means we only really need to configure one pin. So let's go ahead and do that. So we only need to configure the DC pin, and it's actually properly called DC, and it's on the device driver there. So let's go and do that. So before we initialize the device, we need to set that DC pin. And what do we say we want it to be? GP12, right? Let's check. Yes, GP12. Okay, and all the other pins should be automatic. So that means I only need to add one more pin up here. So let's do const byte, and we'll call it TFT DC equals GP12, like that. Okay. And how are we going to know it's working or not? Well, let's go and write some text code. Where should we put it? Here we go. So when we write our tar, like, let's just write it out to both. So we can do here a screen dot clear and a screen dot print. And let's just print the same text onto the screen. And this, when you clear the screen, it resets the coordinates to 0, 0. So this should be in the top left of the screen. We can do the same with this. We can do another screen clear down here. And another screen print. And in this case, let's call this the weight. And let's make a variable called weight. Do that. So we get the same weight coming to the screen as we do to the serial port, like that. All right, let's see if that works for us. Plug the power in. And everything's still looking good. All right, let's F5 that. And we'll run it. Our screen blanked out for a little bit, and then it came up and put something on the right there. What does that look like? It's the tar written backwards. Let me try and put some weight on this. If I pull this, we get some weight. Let's see what happens there. Yep, it's got measured something kilograms, but it's written backwards, right? So the device drivers, display drivers in Hopper have some convenient settings that always work. And what you want to do is you want to use them, right-clicked on initialize there to go to the driver. Before you call device driver begin, you can configure certain things. So I think it's just display. Let's check. So it's flip X. I'm going to flip the horizontal direction. So flip the X direction. And I think it's display driver, not so display driver, because this works for all displays, not just for the current device. So I think that's it. So I'm going to flip the X. And if we go and look at the definition, oh, didn't like that. X flip maybe. Oh, display driver. I keep making these typos. And then we'll go and have a look at the definition of flip X, and we'll see this obviously a flip Y as well, but there's some other stuff too. Actually, we'll first run it, and I'll show you what the effect was. So let's F5 and run it again, and go look at what our results look like. So now our it's been written the correct direction, and if we pull the scale and get some weight, so we'll see the same, the last one that was on the serial port up there. So measured, 0.3 kilograms, and then up on the serial port it also says 0.3 kilograms. So that's the last one. But that's landscape. We want it to be in portrait, right? We want it to be this way up. Well, I do. Anyway, so if we go and have a look at the definition of flip X, I right-clicked on flip X. There's also something called is portrait. So you can flip X, flip Y, and you've got is portrait. And this works for all the Hopper display drivers. So we can just add that too. You just got to set these before you call device begin, because they can only be set once in initialization. So make it portrait, and we'll build it again. And let's run that. There, it cleared. And now it wrote it in horizontal across the top, which is kind of what I wanted, right? And then let's pull this, and it should change to the last weight I measured, which is going to be 1.022. There we go. All right. So that's how you get text drawn on your display and get a display configured. And I think that's a good point to stop this video. And in the next video, I'll focus on drawing our final graphics that you saw in the original introduction. So this is, pretty generic as to how you would set up a display in Hopper, but the next stuff's going to be, more specific to our scale again. So thank you for watching.